Okay, so we have time now for general discussions on this. I want to start with one thing. Richard, so right now California operates under a carbon cap and trade system that just started. How is that going to impact any of us, and how should, and more importantly, I think, how should we tell our legislators, that this should be impacting us?
I mean, one thing you'll see there are lots of parts of AB 32. So one of them is actually in the direction you're working on, which is decarbonizing the fuel source. And so I think the interesting thing there is, can we move from ethanol to some other sort of biofuel that is more carbon neutral? And what you'll see also is that basically gasoline prices will go up. They're going up anyway. One of the more interesting facets there is that your economy is much safer from these oil price spikes if the higher your gas prices are, and the more of the gas price is a tax, because that doesn't change when the prices spike. I think you'll see lots of incentives for alternative fuel vehicles, primarily in the plug-in hybrid and electric vehicles. So what we're doing for the California Air Resources Board to do this is to try to figure out what Shirley was talking about, which was, how do people drive these cars? So does a plug-in hybrid actually generate much more pollution than an all-electric vehicle? And so anyway, that's what we're looking at. We're also trying to figure out where placing charging stations will matter.
Okay. Come on, it's not that close to cocktail hour.
Yeah, my sense is that a lot of the newer technology doesn't yet include the real costs, the environmental costs of all the materials that go into them. And certainly I know from thinking about the deep sea, when people are doing cost benefit on mining all the rare elements that they need for our technology, they haven't yet factored in the cost of environmental degradation and the loss of carbon cycling or other services. And I just wondered if you see us moving in the direction of actually making us pay for the real amount that things actually cost. Or anybody.
Yeah, Shirley might be able to answer questions more on the technology. And let me say, earlier there are very, very big studies that are done on the fuel cycle for coal-based power plants, where they look at, from sort of beginning to mining the coal to the end. And I'm not sure that those same studies have been done with regard to the battery technology. But let me give this to Shirley, who knows more.
Thank you. So at the moment, for example, in Tesla, I think most of the expensive compounds, cobalt, has already been replaced by cheaper elements like nickel, manganese, or aluminum. So the engineers, scientists are well aware of these problem with these rare elements. So I think the more pressing issue is actually in the electric motor, where there's a lot of rare earth elements. I think a couple of years ago, probably heard about the China restriction of export of rare earths, and I think that's, deep sea mining and out of space mining sounds wonderful if it could be realized, but I don't know if I addressed your concerns about.
Well, I think it's exactly that. We're turning to new places to mine, but we don't include the health costs, do we, in the costs of coal and, everything doesn't really include real costs, is my sense.
Yeah.
Actually, for these cost estimates, I mean, the key thing that economists say is you put a price on the carbon that you're generating and putting up. And you can either do that with a cap and trade, because people have to buy a permit and that's the price, or you can put on a tax, which is a cleaner solution. And when they come up with quote unquote what the value of those permits should be, they calculate what the health effects are, and might not like how they calculate them, which we could talk about, but they do that. It's actually the main driving force.
Well, one of the things I've often wondered about is why we can't put a label, because I think many of us as consumers, if we were to go into the store and see the water content of each article of clothing, you know, the 600 gallons for a pair of Levi's or the 300 gallons for a T-shirt, right? Then you would make an analysis, even if there wasn't a cost associated with it, right? You would still make an analysis on whether you purchase that or not. And I think the same would be true for cars and other appliances. If we knew what the total life cycle assessment of it was, we could make some decision. But those things are never posted. I'm sure it's cumbersome to get them on, but why aren't you economists working on that?
People actually have worked on this. So, I mean, what you can show is that there's a segment of the population that it's usually profitable to market to. There's a lot of heterogeneity. You can say, how many of you have voluntarily bought carbon offsets when you took a flight? So if you take a flight on Delta or United or whatever, they will offer you the opportunity to buy a carbon offset. Well, actually, some people do indeed buy the carbon offsets, and some people actually buy green cleaning products and whatever. So there's typically a market out there. I know we did copper on recreation boats, which sloughs off and kills things. But interesting, we found that there was a big group of people who wanted to do the right thing and were willing to pay extra. There was also a group of people who liked the fact that copper killed everything that it came in contact with.
Sorry, back here.
I enjoyed the discussion of the major disasters that you had. On a committee that's a National Academy Committee doing a study called Fukushima Lessons Learned. And what actually happened there, of course, was the reactors shut down, but then the tsunami happened. Power was lost due to the earthquake to many of the stations. But nothing really got bad until the tsunami arrived and wiped out all the alternative power, and of course meltdowns then began to occur in a bit of a disaster. And one wonders, when you look back, how did these things ever get licensed in the first place? And one of the things that we're really thinking about was this coronal mass ejection issue, which potentially, serious enough, could knock out cooling power, let's say, to a lot of stations that are in the U.S., and something that we have not actually considered very deeply previously. But this idea of black swans or perfect storms, which are actually quite different things in terms of the mathematics and statistics, nevertheless are the kinds of things that we look back on and said we should have thought about that. And we don't tend to think about these things. And thinking about the mass ejection things, thinking about these intersections with bolides that we begin to learn are actually a lot more frequent than they were anticipated to be, just simply because we're now measuring them, is a potential area for, I think, integration across the campus that think about a lot more, because it affects so much of what our civilized life, our power systems, water systems, and so on, are all subject to these improbable things that we would rather not think about and tend not to think about when it comes to engineering design.
Yes, I definitely agree that there's a lot of potential for policy considerations, things like that. A lot of that is already somewhat happening. You know, there's Congress, people who are supposed to be in charge of these things. I think a lot of the issues are that the general public doesn't perceive these as real threats necessarily. Maybe there's, you know, one-off events or freaks of nature, things like that. And a big missing component is education of the general public as to what these threats actually represent. You know, I read an interesting piece in one of the National Space Weather Council summary, one of their workshops, where they're saying that, you know, meteorologists should be able to convey the potential for threats from space weather events to the general public, but none of them have the educational background to even begin to discuss it in any coherent terms that the layman would understand, right? So yes, I agree that there's probably a great opportunity for cutting across more than just the sciences here.
Thanks. I'd like to go back to the issue of policies involving cap and trade and carbon offsets. I recently read a book which maybe a couple of you are familiar with it. It's called Green Gone Wrong by Heather Rogers. It has a lot of cautionary tales and disturbing warnings, basically, about how, for example, carbon offset programs often aren't offsetting as much carbon as they claim to be. In fact, in a few cases, they're not offsetting any carbon. And then with cap and trade, there are ways to sort of get around the system. And so, I mean, there has to be some solution to carbon emissions, and there are ways, and people are trying to do that in California. But I mean, do you have ideas of maybe how the policies in California can be improved, I guess, whether it be in vehicles or in gas and energy consumption or whatever?
So the two big ways to put a price on carbon are to do cap and trade, which is to say we're not going to have more carbon emissions than X. And then you give the permits out in some fashion. At one extreme, you auction the permits. But cap and trade solutions are basically popular with existing polluters because they get given out proportionally to how much pollution you're currently doing. They're also more popular because you can have these offset programs for which there's lots of sort of fraud and hanky-panky going on with some of these. And over time, they're getting tightened up. So, and that's the one thing that you can say about any cap and trade system is that it's going to be implemented in a fairly messy fashion to begin with. And over time, it will get better and better. And so the people who look at these things basically accept that the beginning is going to be messy. Most economists would say, look, if you just put a carbon tax on, the public would get the revenue, and you wouldn't have any of these sort of fake carbon projects being created. But anyway, that's a much harder to get put in because the existing polluters are clearly much more in favor of a cap and trade program. And that's typically the cost of getting them to buy in. And what you can show is like dynamically, it doesn't matter that you gave them all these credits and they created a bunch of stuff at the beginning. 10 or 15 years later, there's just the market's working pretty smoothly.
Hi. I would like to add a comment as a student, and I'm saying this as someone who is studying climate science from Scripps, that a big missing portion is the human dimension, or social scientists, the humanities. And I would argue that it's really important because I've attended a climate negotiation event in the past, and I found out, thinking that carbon feedbacks are, some of the biggest uncertainties, or clouds, that really political, economic, and social systems are some of the largest uncertainties. And so we'd love to see more engagement from the social sciences, humanities here on Upper Campus.
Gasoline prices will go up. They're going up anyway. One of the more interesting facets there is that your economy is much safer from these oil price spikes if the higher your gas prices are and the more of the gas price is a tax, because that doesn't change when the prices spike. I think you'll see lots of incentives for alternative fuel vehicles, primarily in the plug-in hybrid and electric vehicles. So what we're doing for the California Air, which is decarbonizing the fuel source. And so I think the interesting thing there is, can we move from ethanol to some other sort of biofuel that is more carbon neutral? And what you'll see also is that basically gas
Okay, so we have time now for general discussions on this. I want to start with one thing. Richard, so right now California operates under a carbon cap and trade system that just started. How is that going to impact any of us, and how should, and more importantly, I think, how should we tell our legislators, that this should be impacting us?
I mean, one thing you'll see there are lots of parts of AB 32. So one of them is actually in the direction you're working